Hello everybody, this is a video for GEO1318 Skills for Geography. It's focused on scientific report writing. So for Skills for Geography, you have two essay assessments, so a formative and a summative. But other modules for written assessments, they might include scientific reports. So for example, your GEO1319 fieldwork in geography, if you're taking that course, then you are being asked to write a report, and it might need to be a scientific report. So we're going to address what makes a scientific report and how it's different to essays. During this video, we are going to look at why scientific reports are important, understand the differences between essays and report writing. We're going to look at the structure of scientific reports and think about how we can include figures and data in reports and do that efficiently and effectively. And we're going to look at how we can describe and interpret quantitative data that we include in reports. There's going to be a series of tasks throughout this video, so you can pause the video, complete the tasks, and then continue. And also, we are going to be using our journals to complete those tasks. So please open your GEO1318 journals and go to the Week 7 Independent Work section. And also on the ELI page, there is the Scientific Report Example PDF that we will also be looking through. So that's a scientific paper that we're going to be looking through too. So if you open up those documents, we'll get started with the tasks. So unlike essays, reports are widely used outside of academia across lots of different types of professional contexts. So learning the characteristics of what makes a good report is a highly transferable skill that you might use not only throughout your degree, but beyond in your future career pathways. Reports have a different purpose to essays, so they are key communication tools that assist in things like decision making, outlining problems and challenges, providing relevant facts and ideas to certain situations, or they might present the findings of a focused study or investigation, and they can potentially maybe recommend a course of action. Essentially, reports are forms of informative writing that outline a set of actions and/or analyses undertaken in response to a specific problem, task, or question. And as a result, they differ from essays in a number of different ways. And this table shows some of those key differences between reports and essays. So reports are typically very formally structured, whereas essays are kind of maybe semi-structured. Reports are informative and fact-based, whereas essays can be more argumentative and ideas-based. Reports are written with a specific purpose or audience, reader, in mind. That might not be true specifically for essays. Also, reports are written in a style appropriate to each section, and they include section headings. So they're very structured, whereas essays are not usually that structured or may not include subheadings. Reports are concise and sometimes can communicate information using bullet points, which we don't typically see in essays. Reports also include data, so they include tables or graphs, which aren't always included in essays, and they might recommend a particular course of action, whereas essays might offer conclusions around a question. So the style of report writing is also different to essay writing. Okay, so essays tend to have a subjective tone containing persuasive arguments and narratives, whereas a report is written in an objective style and is focused on representing unbiased findings and conclusions from the data. So critical thinking, critical writing skills are employed in the construction of a good report. Okay, so this means you have to think logically and present your data and results in a logical way. You have to perform analysis and synthesis, We need to adopt clear and succinct written communication, so reports are concise. Everything needs to be clearly presented, typically in nice confined sections, and key points, facts or analyses are summarised as well. So reports, they're highly structured so that information that they contain can be easily found and understood. So typically there are headings within the report that allow the reader to focus on different parts of the report quickly and easily. Each section is concise and can stand alone from the report as a whole. The structure of a report can be enhanced by using things like subheadings, but also diagrams, tables, equations and graphs are included. So a typical layout for a report that's often adopted for research papers and scientific reports is included here, and is also very similar to the layout of a BSc Geography dissertation report. So there's an abstract, an introduction, methodology, results, discussion, conclusion and references, typically in that order. However, reports don't always have to be constructed in this manner, and also subsections can sometimes be given different headings. So, task 1. Your first task is to complete the table in your journals, adding in your thoughts on the following. So thinking about these key sections of a scientific report, what is the purpose of each of these sections? What should each section contain or not contain? And why are these sections essential for a good scientific report? So, if you pause the video, make a note of your thoughts, and then we'll take a look at a scientific report. So hopefully you have written down some ideas around the role and content of these different subheadings that you find in a scientific report. So we're going to talk through each of these sections now, and we're going to relate this to a scientific report example. Now, scientific papers reported in journals are fantastic examples of scientific reports. So if you can open up the paper that's on the week 7 Ellie page. It is a paper in Marine Pollution Bulletin Journal, and it's written by the authors Wilson et al. And some of these people work at the University of Exeter, at the Penryn campus, but also in the Greenpeace labs here on the Stretton campus as well. And the title of this report is The Influence of Depositional Environment on the Abundance of Microplastic Pollution on Beaches in the Bristol Channel, UK. So you will be used to seeing scientific papers now, and again, most papers will adopt a very similar structure to the one on the previous slide. So we have the title, we have the authors, and the first thing we see is the abstract. So this is a very brief summary of the entire paper. It includes the rationale, why this work was performed, the importance of this work. It will touch on the methods. It will present the main results and findings in a very concise way. It typically should not contain references and is quite succinct. So then the next section of this paper is the introduction. Okay, so this introduction provides a wider regional or scientific context of the study, including the rationale for the work and analysis undertaken. Okay, so this is kind of like the background to why this work is important. Now let's look at the methodology. This is typically next, and this is a brief description of the methods involved in the collection and analysis of the data presented in the study. And you need to include enough detail so that the study could be replicated. You can see in the paper that they have this really nice image of their sample collection as well. So they've mapped out where they collected their sample, and you'll note that there is a figure caption, and these figures are presented in a series of panels. So the methodology, how they performed their analyses. The next section is a results section, and sometimes in some papers you might have a combined results and discussion, but usually they're separated out into separate results followed by a discussion section. So the difference between a results and a discussion section is that the results, you are briefly describing the key trends or patterns in your data. And that is a sort of very descriptive approach. And in your discussion, you then go on and interpret and discuss those results. Okay, your results section should contain most of your data-based figures and should therefore be largely descriptive as well, leading on to the discussion. So the next section is your discussion, and it places your results in the wider context of the existing literature. So in this section, it's typically the longest section of your report because it contains all of your explanations, exploration and evaluation of the data, and it draws on the existing literature to support the key themes you're pulling out from your data. So it's the longest section and will contain sufficient references to support what you found from the literature. This is followed by a conclusion, so a short section that summarises, concludes your key findings, and might potentially offer a suggestion for future research, or again, it might just really hit home the significance of this work and what it means in the wider context. And then we finish up with a reference list. So here you've got all your references, typically alphabetically ordered, and is a comprehensive list of all the literature that you have cited in your report. Now, you will frequently be expected or required to include figures and data in your scientific reports, okay? And if executed well, effective figures are a really useful way to communicate your findings. Figures might include things like maps, graphs, tables, diagrams, flowcharts embedded within your report. So it's really important that the figures that you include are appropriate, they're of a high professional quality, and they communicate the information that you need them to effectively. And this is true for both scientific reports and essays. It's really important that you accompany your figures with a caption, a figure caption, and you can see in this paper that they have done that. So you have your figure and then you have a figure caption next to it. So understanding what should be included in a figure caption is also really important, and we're going to look at that in a moment. One of the key things as well to think about is the units that you're presenting your data in and getting that correct. And sometimes even highly skilled professionals might get that wrong, and you can see that the paper that we've been looking at by Wilson et al. Actually had to add sort of an amendment to their publication because they had presented incorrect units for their work. Okay, so again, it shows that even the best of us can sometimes get this wrong. So really understanding the data you're putting into your figures is really important, and making sure that's reflected in your figure captions too. Okay, so we are now moving on to task 2. So here we have a figure showing monthly average atmospheric carbon dioxide concentrations as measured in the Mauna Loa Observatory in Hawaii. What we'd like you to do is to spend some time critiquing this figure and write down 3 ideas for how this figure could be improved. So if you'd like to pause the video, complete the task in your journal, and then we'll move on and look at how this figure can be improved. So hopefully you have a few suggestions on how we can improve that original graph. And here is an improved version of the same figure. So on the left, we've got that original graph that was produced in Excel, and it's kind of like the default graph. And on the right is the improved figure. The data is identical, both figures were produced in Excel, but we've made just a few adjustments here to really make the figure really convey the information that we want it to. So let's talk through some of these aspects of this improved figure. So when it comes to chart titles, in scientific reports we tend not to give figures or diagrams titles. Instead we use figure captions to convey and describe what the figure is and what it is showing. So figure captions are typically not included in the word count of a scientific report. However, double check your assessment brief. They will vary, so find out if your figure captions are or are not included in your word count. But the figure captions are used to provide important information about the figure and the data that it is showing. They should be predominantly descriptive and should not be used as a way of circumventing the word count. You can see here in this figure caption, we've got monthly mean carbon dioxide measured at Mauna Loa Observatory in Hawaii. A second order polynomial trend line is fitted to the data to demonstrate the overall upward trend through the time series. Data obtained from the Global Monitoring Laboratory. So here we've explained in a really concise way what that data is. We've shown that we're looking at carbon dioxide measurements. They're highlighted in blue, and we've included that in the figure caption to really direct the reader. And then we've talked about the polynomial trend line that's been applied, and in brackets we've got that in red. So again, we're making it really easy for the reader to understand the data we're showing. We've also included where we've got this data from. So if you're not presenting your data, if it's not your original data, and you've got it from an external reference, then you need to cite that. So that's what we've done in that final sentence. And then that reference will be included in the reference list as well at the end of your report. Axes labels. So when we look at the labels, that original graph didn't have any, but they're really vital so that we know what the numbers, what the data is actually representing, okay? And it's really important to also include what units are being presented as well. So here we've got carbon dioxide parts per million, ppm. Okay, and thinking about that paper we just looked at, make sure you get your units correct. Okay, and if you needed to provide further information around the units, then you can provide that in the figure caption if you needed to. Also, the axes ranges have been improved here. So you can see along the bottom, the year pretty much has stayed the same. However, the carbon dioxide concentrations we've changed here so that it fits the data. So it's showing that upward trend. In that original figure, it's almost a horizontal line, which doesn't really tell us much. So we've fitted the y-axis so that it more clearly tells the story revealed by the data. So instead of having the axes from 0 up to 1,000, we've brought that down. We started at 300 and gone up to 440 parts per million. Okay, so it tells the story of your data. It's also really important to think about the text size and the figure size, and that ratio, having a good balance between the size of the figure and the size of the text within it. So you should always check that your figure is legible and we can read the axes. It's really important that we can actually read that information. You can also see here on the year, on the x-axis, those dates have been rotated as well, making them easier to see. So here is a summary of those top tips for a good figure. And also what's really important is that you always refer to your figure in the text of your report, okay? Figures should be presented and numbered in the order which they are mentioned in the writing. And here at the bottom of the slide are some examples of how you can refer to a figure within the text of your report. We're now moving on to task 3. So here is a figure showing a map of a study site located near the Eden Project in Cornwall. So what I'd like you to do is critique this figure and write down 3 ideas for how this figure could be improved. Again, you'll find this task in your journal, so pause the video to complete the task and then we'll take a look at how this map can be improved. So here is an improved version of that original map, figure 2 improved, and I'm going to talk you through some top tips for improving your maps. So Google Maps, there's no denying the usefulness of Google Maps, and especially if you're not in a position to make your own map using GIS or other software, but try to tidy that map up a bit and avoid including too much of the Google Maps interface in your final figure. If you'd like to create your own maps, then you can using the university's subscription to Edina's Digimap service, and then you can find out more. There's a link on the next slide. So think about your map type, right? What are you trying to communicate using your map? Is it just the location or the context of the surrounding area? So sometimes a satellite image might be enough, but it's also helpful to think about what other maps or styles of maps might be useful. So here we've included an insert into panel A, where we've got the location of the Eden project within the national context. And then also caption B is showing more detail around the topography of the map with some annotations as well. So annotations, it can be really useful to annotate your maps. So provide the context to the reader. Again, if you're adding on text, make sure it's legible, and also use colour schemes and size of lines that work. Also, as with this map, we have these different panels, okay? So if you can label your panels, here we've got A and B, that makes it much easier to describe what's going on in your figure caption and relate to these different captions then in your results or discussion. As with all figures, your map should also have a caption associated with it. And again, like I just said, you need to be able to refer to that directly in the text. So, direction and distance, your map should always include a north arrow and a scale as well. These are really important things to remember. Here is a summary of some top tips for map creation that we've just highlighted. So, how do we present our data? What is the best way to present our results? There are many ways of presenting data. You may need to take your raw data or results and put those into tables, graphs, charts. There are lots of different ways that we can do that, and there are some ideas presented here. But there's also a really good resource, if you click on the link on the Ellie page, that really presents some nice high quality figures and can get you thinking about the different types of ways you can present your data. The way that you present your data is all dependent on the type of data and the messages that you want to convey. Okay, so it's very specific to your data, but hopefully this resource will inspire you thinking more creatively about how you can present your data. Now, tables can be an effective and appropriate way to show data. You might want to show raw data or results or some kind of key information in your report. We are now going to attempt task 4, where we want you to improve this table. So have a look at this table below, showing manufacturing sales in Canada in 2008, and think about 1 or 2 ways that this table can be improved. Again, you can pause the video and then we'll address some of the key things that a table needs to include to be effective. Let's talk through how that table could be improved. Here is an improved version. That original table was really confusing, really difficult to kind of follow and understand. So thinking about the design and the layout of your table is really important, okay? You want it laid out in a really straightforward, easy to understand way, so it makes it really easy for your reader to pull out the key points of your table. Make it easy for the audience to find and understand the important numbers within your tables. Also remember to include units, and also tables are required to include a table caption to help give key information about the table to the reader. Okay, what are we looking at? Unlike figures, where you have a figure caption below the figure, for tables the caption usually comes before, just above the table. So, how can we make our tables effective and easy to understand? Avoid unnecessary text, okay? Keep it simple, keep it concise. Your columns should be evenly spaced and not too far apart. you want to display your data in some sort of order. So it might be chronologically for time series or by some other standard classification. Okay, so for a longer time series, it may be more appropriate to use reverse chronological order, so starting with the most recent period and going backwards in time. Depends on the data. Use minimum of decimal places, okay, and keep your decimal places consistent. In that other table, they weren't, and it made it really difficult to actually relate those different data points. You don't always have to center your data, but you may find the best way that you prefer to present your data is centered, or it could be justified to the left or right, just to be consistent. That will make it much easier to read that data. Don't leave any data cell empty. Missing values can be identified as not available or not applicable. The abbreviation N/A can apply to either of those options. So again, it needs to be defined, and you could put that information in the figure caption. So on the next couple of pages, I've just summarised those top tips for tables, and you can refer back to this guidance on figures and tables as you come to plan to use them in your reports or in your essays. To find out more about how to ensure you can produce good and effective tables, there is a resource on ELI that is also very useful as well. So again, check that out in your own time. So now we know how to include data, include effective tables and figures appropriately in our scientific reports. The next step is being able to interpret and describe that data effectively. So for tasks 5 and 6, these are the final tasks. They're embedded in your journal, and I'd like you to work through those after the video and have a think about how you can effectively describe and interpret your data that in the figures that you include in scientific reports. Again, you can just read through this in your own time, and there are tasks built into your journal to get you really thinking about the correct language, the correct terminology and logical approach that you need to adopt when addressing figures in your reports. You now know the role of scientific reports and how they differ from essays, that scientific reports are highly concise and structured, with each section performing a specific role. You know how to appropriately design and include figures, maps, tables in your reports. And when you complete tasks 5 and 6, that will allow you to understand the language that we need to use to describe and interpret quantitative data in your reports. Be sure to take a short break before you attempt tasks 5 and 6 in your journals. But hopefully this has been a useful introduction to scientific report writing.